Okay, so we're going to look at how to do this assignment 1. First thing we need to do is open Minitab. So once you've downloaded it, you should have here at your desktop a little icon there. So I'm going to double click on that. And it says Welcome to Minitab. Okay, so let's look at this assignment. So what we have to do first is to take this probability distribution and place the x values in column 1 and place the p of x values in column 2. Okay, so I'm going to do that. So in column 1, I'm going to have 0, 1, 2, 3, 4, 5, 6. Then I'm going to scroll over up to the top of column 2, and I'm going to put my p of x values, 0.001, 0.003, 0.025, 0.111, 0.279, 0.303, and 0.278. I'm going to do a quick check and just make sure I've entered it correctly, because if I make a mistake here, everything will be wrong. Okay, so I've got that in there. Now let's see what they're asking me to do next. I want to simulate a sample of size n equals 12 from this population. In fact, I'm going to be simulating 2,100 samples of size 12. So from the top menu, select Calc, Random Data Discrete. Once the window opens, number of rows to generate is 2,100. Okay. So Calc, Random, Discrete. Number of rows to generate, I want 2,100. Now let's look at the directions. Store in columns C3 through C14. So I'm going to have 12 columns there. And I'm going to be taking the values for this calculation in column 1 and column 2. And then I click OK. All right, so I want to store in column C3. So when I just click here, the C1 and the C2 come up automatically. So this is my input data. So I want to click in C3 through, so dash C14, and my values, my x values are in column 1, and then my probabilities are in column 2. And then I'm going to click OK. And it's going to generate 12 new columns. Okay, and so what I've got, if we scroll down here, I've got 12 columns and I've got 2,100 rows. Each of the rows, so let me get this all the way back up to the top. So here is my first sample, my first random sample. See, it's got 12 randomized values, x values, so numbers between 0 and 6 in this first sample. Here's my second sample. So they're randomized, but they're depending on these probabilities. Okay, so this is why you don't see the number 0 pop up too often, do you? Because look at the probability of getting a 0. You don't see the number 1 pop up too often, do you? Look at the probability of getting the number 1. But, I mean, it can happen. So here is my first sample of 12 randomized values from, according to this probability distribution. There's my second sample of 12, my third sample of 12. So my rows are my samples. So what I want to do now is, let's get back on the directions. To average the sample observations, follow the steps in Minitab. So from the top menu, now I want to look at each of these samples. So those my samples are rows, and I want to get the mean of each of those samples. Okay, so for this sample, I want its mean, and I'm going to store that. I'm going to leave a gap here in column 16. For the second sample, I want to figure out what its mean is, and I'm going to store that in column 16. So in order to do that, I'm going to go to Calc. This time I want to look at the rows. So for my row statistics, I want the mean value of each of those samples of 12 in the rows. So for input variables, so when I click here, all of the columns show up. Input variables, I want columns 3 through column 14. And I want to store the result in column 16. And then click OK. So this is showing me that the mean for my first sample is 5. Okay, this is showing me that the mean for my second sample is 5.08333. Okay. So now let's go back to the instructions. So each row represents a sample of observations, a sample of 12. The values in C16 are the sample means of the sample observations from C3 through C14. So C16 is the mean for all of those samples. Now let's look at question 1. Use Minitab to find the following descriptive statistic for the sample means. So I want to take that column of all those sample means, and I want to find the mean of that column of means. And I want to find the standard deviation of that column of means. So let's go back. And so I think I'm going to calc. Now I want to do a column statistic. And I want to find the mean. And I want to find the mean of all those values in column 16. Whoops, column 16. And just leave it blank because it will print the result up here in my session. Okay, so the mean of column 16 is that number. And so back here on my sheet, that's the number I would put in there. And let's find out what the standard deviation of column 16 is. So that column of all my mean values. So let's go back to Calc. Let's do a column statistic. Now I want the standard deviation. I want the input variable to, it's already there, default from the last one. And again, I want to store results, make that optional so it will print up here. So it's giving me my standard deviation. And so I would write that in here. Now attach the Minitab output. It's really important that we only want this information here. We don't want to print the worksheet. If you print the worksheet, you've got 2,100 rows, and it'll be a ton of paper. In fact, at the bottom of this, it says do not print the worksheet. The worksheet, you get 2,100 rows. Now, another way to print, so I've put a link in Canvas on how to print. Another way to print is if you have Word, you can highlight that, press Control-C, then open up a Word, get a new file, and do Control-V. And it's going to store it there. And say up at the top, put my name. And I can clean that up a little bit now, so I can like put those together. So that was the answer to question 1. There. So that's my answer for question 1. So I can do it like that, so I can save it. And I can put it there. I can save it somewhere where I can have it. Okay, so that's one way I can do that. All right, so create a histogram and normal probability plot for the sample means in column 16. Okay, we will talk about normal probability plot. Let's look at creating a histogram. Okay, now this is where our results may differ. Okay, what you have may or may not be normal, and your histogram may or may not look like mine. Okay, so I'm going to go to Stat. No, I want to go to Graph. Sorry, not Stat, to Graph. There we are, histogram. And I'm going to go with the default one, the simple one. And I'm only going to use, because we were told, create a histogram for column 16. Excuse me. So the graph variables, I'm just going to use columns. I could type that in, or I think I can double click on that and it puts it in there. And I'm just going to press OK. Now, this has got gaps, and I would like it not to have gaps. So what can we do? You can double click on one of the bars. And then we need to get here where it says binning. And we need to come down here for number of intervals. They've got 42 intervals on this. And I want to decrease that and say just have 10. So I only have like 10 bars. And then click OK. That's much better. So I'm really liking that. And so I'm going to stay with that. Now, if I want to let's see if I can get it to, no, I was hoping I could get it to copy up in here, but I haven't been able to find that. I can get it printed out separately, but if I want to add this to my append graph to report, I can send this to Word. Let's see if I can append it to a report. But if I want to save this, I can again click Control C. I should be able to do that and come back here and Control V. There it is. And so when I get here, I can put question 2. And I can also make that smaller if I want to. So I can click down here at the corner and have it smaller so I can fit everything on one page. So again, I'm going to save that. All right, and let me just put that down there. And then it says do a normal probability plot. Okay, so I'll go to Stat. No, I go to Graph. And now I want a probability plot. And I'm going to do the default one. And again, I want column 16. So that's my probability plot. And now again, if I click here and just press Control C and come back here, I should be able to put it do Control V. And if I want to get it on one page, I can make it a little bit. There, so I've got all that on one page. Let me save that. Okay, now, what is a probability plot? And how are we going to use that to answer this question? Is the distribution of column 16 approximately normal? Okay, and explain your answer. So that's what you want to do either here, or I can do it on my Word document. Explain your answer by referring to both the graph and the distribution. Okay, so by the histogram graph, we can definitely see, and you might even want to take a red pen, and you can see that that is definitely bell-shaped, and that is normal. Now, how can you tell from a probability plot whether or not you have normality? Okay, so that is something we have still yet to talk about, but it is covered on the exam, and I was saving it until we got to this homework assignment. Now, our book does not call it, unfortunately, a probability plot. So let me get back to... so this is in section 2-2 in the histogram section, assessing normality with normal quantile plots. So that's what they call a probability plot, but the department here says probability plot. Okay, well, criteria for assessing normality with a probability plot. For a normal distribution, the population distribution is normal if the pattern of the points in the probability plot is reasonably close to a straight line, and the points do not show some systematic pattern that is not a straight line pattern. So we got to be really careful about that last sentence there. So let me just get one on the screen. This is not normal. Yes, they are all reasonably close, very close to a straight line, but there is something else, another pattern that's going on here. And so I'm just going to lightly pretend to, it's actually looks like it's coming up here and kind of looping a loop and going around. And so let me just draw what else looks to be going on here. This is kind of doing something like that. And there is something else going on there. And in fact, that's what we get when we have a uniform distribution. This is not a normal distribution. In fact, this is going to look like it will correspond to a skewed distribution, because it looks like if we do those points, looks like we've got something like that going on. Now, this is considered a normal distribution. We do have points, and they are close to the line, and there doesn't seem to be another pattern going on. There's no other systematic pattern that's not a straight line pattern. So even though these points were closer to the line, there was another systematic pattern that was not a straight line pattern. Okay, and let me give you some more examples from the book. Okay, again, this would not be considered normal. That would be a uniform distribution, very, very close to the line, but we've got these little tails, and it kind of loops above and then goes under, and we definitely have a pattern there, a systematic pattern that's not a straight line pattern. This would be something that would be skewed. We've got something else going on here. Again, these are close to the line, but we've got some kind of pattern here that's not a straight line pattern. And then here's the answer here. Only part C appears to represent data from a normal distribution. So the points are very close to the line, and we don't have some kind of systematic pattern that's going on that's not straight line. Okay. Let's see if I can find some more. Okay. So in chapter 6, section 5, here's some more information. They call them normal quantile plots. That's what the histogram looks like. And from our normal quantile plot here, they're very close to the line, and there's not a systematic pattern. Okay, and you might think, oh, well, this looks like it's going like that. No, it's not. Whereas you can see how it's here, we definitely have a systematic pattern, and how straight how those points all conform to that. So now, if I had, say, maybe another point down here and down there, oh gosh, I didn't mean to color that in. Then that would be deviating away from it, but that's not quite enough. So if I'd had other points like down here, down here, down here, and then up here, and up here, then that would be more conclusive that we've got some kind of other systematic pattern, but we don't have that. See, this is uniform, and this is what we expect on uniform. We've got that pattern, very unique pattern there. Here I've got a right skewed distribution, because remember the skew is where the tail is. And over here we can see all those points. That's definitely not giving us a straight line pattern. Here I've got something that's left skewed, because the tail, I have a left tail, and this is what its probability plot looks like, and that's not going to be a normal pattern. Let's see if I got some more pictures. The answer to that would be yes, that appears normal. Very close to the line, and there's not another pattern going on that's nonlinear. Okay, so what do we think about number 6? I would also call that normal. Very close to the line, and there's not a distinctive pattern cropping up that's nonlinear. Number 7, no. Okay, I do have this nonlinear pattern that's coming up here. And with that no, we're going to have something skewed there, aren't we? Okay, so I hope those are enough examples that you can see what we mean by probability plot. Okay, let's look at some other questions. Estimate the chance of observing a sample mean that is at least 5.0. Okay. Well, it's a normal distribution. And if I want to find the probability, so the chance or the probability, so that's telling us probability, I'm going to want to find this shaded region here, aren't I? Now I can do that, but I have to, that's an X score. I have to convert that to a Z score. And then find the right area. So I have the mean and the standard deviation. So the mean is 4.67643. I'm going to take it as many decimal places that they give to me. Standard deviation for mine is 0.315083. Okay. And let me get this back. So if I want to convert 5 to a z-score, I'm going to have that. And so 5 minus 4.67643, all divided by 0.315083. And so my z-score is equal to 1.0269356. Okay. And let's see what I can do on second vars. On that inverse normal, I believe that's the one where if you put the z-score in, it'll give you the left area. So let's see if I remember that right. So take my most recent answer. Oh, sorry. Okay, so no, it's not inverse normal. I get on inverse normal, you want the area, left area. Okay, so if I want to estimate the chance of observing a sample mean that is at least 5.0, so 5.0 or more, then I want this area. I convert this to a z-score. There's my z-score. So then I'm going to do inverse vars, and it's normal CDF that I want. And so I have to give it a left limit, a z-score, which will be 1.0269356, comma, and then a right limit. And so these never touch, and so just to be safe, I'll do 1,000. And so my probability of, or the chance of observing a sample mean that is at least 5.0 is going to be 1.52. Now a mean that's greater than or equal to 5 is going to be 0.15 if I just take it to 2 decimal places. Okay. Now, what would have happened if I did not have a normal distribution? If I didn't have a normal distribution, I couldn't use this method. And so what I could have done, remember probability of event A happening is the number of ways A happens over our total sample space. So suppose I did not have a normal distribution. Let me put that down here. Then I'd want to count up how many things in column 13, how many means were 5.0 or more, divided by the total number of data values in column 13, which is 2,100. Now, I've got 2,100 things, and they're all just in a various orders. So I want to order column 16. So if I remember this right, maybe it's data. Yeah, okay, so data, I want to sort. I want to sort the data in column 16, and I want to take that from decreasing order. So biggest to smallest. And which column do I want to sort? Just a specific column. And column 16. And I'm going to press. Okay, now column 17 has column 16 all sorted. So I want to know how many are 5.0 or bigger. So I just have to go down here until I get the last one that's 5.0. So keep your eyes here and just hold this down. Be ready to let up. because we're getting close. Okay, now I want the probability that it's 5.0 or bigger, so I need to find the first instance of 4 point something. Okay, so how many items in column 16 were 5.0 or bigger? Well, what is this row? That's the 414th row. So the probability of getting a mean, because column 16 was all mean values, is the number of values greater than or equal to 5 divided by the total number of values. And what was our row number? I forget. Okay, so we have 414 values that are 5.0 or bigger. And so that will be my probability. Remember, probability is always a number between 0 and 1, inclusive. And so for that one, if I want to take it to 3 decimal places. So if my data had not been normal, I could not have used the method I did here. And your data may or may not be normal, okay? So if it had been normal, the only way I could have answered this last question was to figure out how many means were 5.0 or greater, and out of the total, and then that would have given me my probability. Okay, so that should answer all questions.